We will be looking at further examples of stoichiometric reactions and the concept of limiting reagents. As another example, we have a question that states sodium is a soft reactive metal that rapidly reacts with liquid water to give hydrogen gas and an aqueous solution of sodium hydroxide. How many grams of sodium metal are needed to produce 7.81 grams of hydrogen by this reaction? So we first need to start out with a balanced chemical reaction. We're going to take the words in the first sentence and translate that into the symbols of a chemical reaction. So in this case, the two reactants are sodium metal and water. So we write the atomic symbol for sodium and the formula for water, H2O. Those two things combine to be our reactants. We then have an arrow, and the products are the hydrogen gas and sodium hydroxide, which we write the formulas for those two species, hydrogen being a diatomic element. At this stage, we need to balance the chemical reaction. We see that the sodiums are balanced, so we have one sodium on both sides. If we look at the hydrogens, we have two hydrogens on the left, but three hydrogens on the right. If we put a half in front of elemental hydrogen, a half times the 2 would give us one hydrogen atom, and then one additional one in the sodium hydroxide. So that balances the hydrogens, and then we see that the oxygens are balanced. There's one oxygen in water and one in the sodium hydroxide. At this stage, we need whole numbers, so if we multiply everything by 2, we can come up with our balanced overall chemical reaction. We then include our phase designations. Sodium is a solid, like most metals at room temperature, and of course water at room temperature would be a liquid. The hydrogen is going to be a gas, and the sodium hydroxide is an aqueous solution, so we use AQ. At this point, we're going to start with the given in the question, which is the 7.81 grams of H2 gas. We need to first convert that into moles by using the molar mass of H2. We then cancel the grams of the hydrogen. This gives us the moles of H2, but we need to do the then stoichiometric ratio between the H2 and the goal of the question, which is the sodium. So that ratio is 2 to 1 from the balanced chemical reaction. And so that cancels the moles of H2. And then we need to do one more step to go back to the mass of the sodium. That is the atomic mass of sodium from the periodic table. And at this stage, the moles of sodium would cancel. And at this stage, we have the units and the formula of the goal of the question, so we can solve this mathematically by multiplying everything in the numerator and then dividing by everything in the denominator. So essentially, we have 7.8 times 2 times 23 divided by 2.016 gives 178.1 grams of sodium. We see there were 3 significant figures in 7.81, so our answer can only have 3 sig figs. We see that the first insignificant digit is a 1, so we are going to round down. That gives us a final answer of 178 grams. At this point, we need to discuss the concept of a limiting reagent. The limiting reagent is a reactant that will be consumed first in a chemical reaction, and so typically then the other reactant that is involved would be in excess. So the two species are not necessarily, or the two reactants are not necessarily mixed together in exactly the right stoichiometric ratio. The crucial concept associated with a limiting reagent is that the moles of products that will be formed will be limited by the number of moles moles of the limiting reactant. So in other words, this species, if it runs out first, will then no longer allow for any further production of products. In order to make this concept clear, we can draw an analogy to the recipe for making some sort of food item. In this case, we're going to make an ice cream sundae. And so the combination that might be required to make an ice cream sundae would be 2 scoops of ice cream, and then 1 cherry, and some chocolate sauce. And this might be 50 milliliters. We combine those in that appropriate ratio and we come up with 1 sundae, ice cream sundae. So the stoichiometry for this reaction is 2 scoops for every 1 cherry, and combined with 50 milliliters of the syrup produces 1 sundae. This ratio would need to be maintained when we need to produce multiple numbers of sundaes. So again, we have our balanced reaction for producing a single sundae, but if we need to have more sundaes than that, let's say that we start with 8 scoops of ice cream. If there was a situation where we then also had 6 cherries, all right, in this particular case, then we can combine that with 100 milliliters of syrup. And we have to ask ourselves, how many sundaes could be produced with these amounts? Well, if we have a ratio of 2 scoops of ice cream for every 1 sundae, then we can figure out that if the other 2 were in excess, we would be able to produce, in this situation, a total of 4 sundaes, which is fairly obvious, okay? But if we do the same calculation with the cherries, this ratio is 1 cherry for every 1 sundae. In this case, if the cherries then cancel, we come up with a total of 6 possible sundaes. But finally we consider the syrup. We have 100 milliliters of the syrup, but we know the ratio is 50 milliliters for every 1 sundae. So the syrup only allows us to produce 2 sundaes. So with this combination of 8 scoops of ice cream, 6 cherries, and 100 milliliters of syrup, the maximum number of sundaes that we can make is the smallest from each of these calculations, which is the 2 sundaes. And so it turns out that we would have a situation where there'd be 4 leftover cherries, and in fact there would also be 4 scoops of ice cream that would be wasted. As a further example of how to determine the limiting reagent, in this question, if we have 1 mole of elemental oxygen, O2, and it's burned in combination with 1 mole of H2, we can ask ourselves which one of these 2 reactants is going to be the limiting reagent. So, first of all, we need a balanced chemical reaction, so the ratio between the elemental oxygen and the elemental hydrogen is 1 to 2, and that will then produce 2 moles of water. If we then start with the given in the question in terms of O2, 1 mole of elemental oxygen, the stoichiometric ratio from the balanced reaction between the O2 and the water is 2 to 1. This then gives us canceling of the moles of O2, and this should produce 2 moles of water. If we likewise start with the hydrogen, if we have 1 mole of elemental hydrogen and use the ratio between the hydrogen and the water, this is a 2 to 2 ratio, we should also end up with then a situation which is 1 mole of water. The smaller of these two quantities from the calculations will tell us the identity of the limiting reagent. And so it turns out that the hydrogen will be consumed first and therefore is the limiting reagent. And the maximum amount of water that would be produced would be 1 mole. And in other words, the O2 is in excess. As another example of a limiting reagent type problem, we have an example here of aluminum chloride is produced by the reaction of hydrogen chloride gas and aluminum metal, and that hydrogen is a byproduct of this reaction. So how many moles of aluminum chloride can be prepared in a reaction vessel containing 0.15 moles of aluminum and 0.35 moles of hydrogen chloride? Our first goal is to figure out what are the formulas for the reactants and products so that we can write a balanced reaction. So to do that, in the case of hydrogen chloride, in this case the hydrogen would be H plus and chloride would be H minus. So the situation of combining those two ions produces a formula of HCl. The aluminum metal, since it's a metal, we would simply write the atomic symbol. So then we have aluminum chloride. Aluminum's ion is 3 plus, and again chloride is 1 minus. So in this particular case, if we do the crisscross, we would end up with a formula that is AlCl3. And then finally, hydrogen is one of the diatomic elements, so you should know that the formula is H2. The next thing that we need to be able to do is to write a balanced chemical reaction. So in this case, the reactants are the aluminum and hydrogen chloride gas. The products are the aluminum chloride and the hydrogen gas. If we start with balancing the aluminum, we see that we have 1 aluminum on both the reactants and product side. If we then turn our attention to the chlorine, we see that there are 3 chlorines on the right-hand side and only 1 on the left. So if we put a 3 in front of the HCl, that would balance the chlorines. And then finally we turn our attention to hydrogen. There are 3 hydrogens on the left, but only 2 on the right. So we would use a fraction of 3 halves to balance the hydrogens. But of course at this stage we need to get the lowest whole number ratio. To do that we would multiply all of these coefficients by 2, which then gives us a balanced overall reaction as seen here. Finally, we need to do our limiting reagent calculation starting with the givens in the problem. So how many moles of aluminum chloride could be produced from each of the 2 given moles of reactants? So if we start with the moles of aluminum and use the mole ratio between the aluminum and the aluminum chloride, in this case then from the balanced reaction the ratio is 2 to 2. So in this case then we would cancel the moles of aluminum and come up with 0.15 moles of aluminum chloride if the aluminum was the limiting reagent. Conversely, we can start with the moles of the hydrogen chloride, and in this case the ratio is 2 to 6. And if we then cancel our units and solve for the moles of aluminum chloride here, you see that you get 0.1166, which we would round to 0.12. That turns out to be less than the number of moles of aluminum chloride we would form from the aluminum metal. So therefore, this is the maximum amount of aluminum chloride that could be formed. It also then tells us that the HCl is the limiting reagent and the aluminum is in excess.